This is Bob Capetta from the College of the Florida Keys, and this lesson is on Gaussian elimination with back substitution for a 3x3 system with a unique solution. So let me remind you of the process. We have a 3x4 matrix. We're going to engage in row reduction to get an upper triangular matrix. Now that sounds very complicated, but let me describe the process. Step one is to get a number 1 in this upper left corner. Now, oftentimes we can just start with a 1 there, or we can move the equations to get a 1 in the upper left. If we have to, we could divide everything by a certain number to convert that first coefficient to a 1. Once that's there, the 2 underneath need to become zeros. So 1 in the upper left, then a 0 directly below that, and another 0 directly below that. That's how this process starts. Now I've got to create a new 1 in the middle. So this middle asterisk is going to become a 1 next. So I might need to divide or multiply both sides by some number to get that. But we need that to be a 1. Then we use that 1 to convert the number below it into a 0 by multiplying and adding. And finally, we need a 1 in our last spot. Again, typically by multiplying or dividing. This is what we want for Gaussian elimination with back substitution, and this is the most efficient algorithm for solving this sort of a system of equations. So that's the strategy we're going to stick with. So let's take a look at an example. X minus 2y plus 4z is negative 7. 2x minus 3y plus z is 5. And 3x plus y minus z is 4. We're going to make an augmented matrix. First column of coefficients, 1, 2, 3. Second column of coefficients, negative 2, negative 3, 1. Third column of coefficients, 4, 1, negative 1. And then we're going to draw a vertical line to augment the matrix with the answers of negative 7, 5, and 4. You'll recall our first strategy was to get a 1 in the upper left. We could always switch the order of the equations if I have a 1 somewhere else, but I have a 1 in the upper left. That'll make it a little easier. And I've got to make this 2 underneath it into a 0. I've got to make this 3 underneath it into a 0. How does the 2 become a 0? We will say row 2 is negative 2 times row 1 plus row 2. Because negative 2 times 1 is negative 2. When I add that to 2, I'll get 0. So what is negative 2 times row 1? That would be negative 2, positive 4, negative 8, positive 14. And I'm going to add that to row 2 of 2, negative 3, 1, 5. The goal is to get a 0 in this slot. Negative 2 and 2 is 0. 4 minus 3 is 1. Negative 8 plus 7 is negative 7. 14 plus 5 is 19. So this becomes my new row 2. So row 1 and row 3 stay the same. This 0, 1, negative 7, 19 becomes my new row 2. Next up, we want to convert that 3 into a 0. So we're going to multiply the first equation, the first row, by negative 3 and add that to the third row. So negative 3 times the first row plus the third row is what we want for our new row 3 to pivot on the 1 to turn the 3 into a 0. So negative 3 times 1 is negative 3. Negative 3 times negative 2 is 6. Negative 3 times 4 is negative 12. Negative 3 times negative 7 is positive 21. We're going to add that to row 3. 3, 1, negative 1, 4. Negative 3 and 3 is 0. 6 and 1 is 7. Negative 12 and negative 1 is negative 13. 21 and 4 is 25. So this now becomes my new row 3. So we had a 1 in the upper left, and then we had a 0 underneath and a 0 underneath. That's the first part. Next, we've got to come to the middle and make that a 1. It already is a 1. If it hadn't been a 1, we would multiply or divide the whole row by that number to make it a 1, but we saved a little bit of work here by giving us a 1, so I don't need to concern myself with that. So my next goal is to pivot on this to make the 7 a 0. Remember our process, 1, 0, 0, 1, 0, 1. So I've got to turn this 7 into a 0, so I'm going to multiply the second row now by negative 7. So it'll be negative 7 times the old row 2 plus the old row 3 will give me the new row 3. Negative 7 times old row 2, negative 7 times 0 is 0. Negative 7 times 1 is negative 7. Negative 7 times negative 7 is positive 49. And negative 7 times 19 is negative 133. Please do not be afraid to use a calculator for that kind of multiplication. Add that to row 3, 0, 7, negative 13, 25. And you'll notice 0 plus 0 is 0. Negative 7 plus 7 is also 0, which I want the 0 here, which is good. 49 minus 13 is 36. Negative 133 plus 25 is negative 108. So that becomes my new row 3, 0, 0, 36, negative 108. Again, our process, 1, 0, 0, 1, 0. Now this has to become a 1. It is a 36. So I'm going to take my entire row 3 and divide that by 36 to get it to be a 1, to get the final form that I want. So indeed, I'm going to say that the new row 3 will be the old row 3 divided by 36. 0 divided by 36 is 0. 0 divided by 36 is 0. 36 divided by 36 is 1. And negative 108 divided by 36 is negative 3. So that becomes my new row 3. And at that point, we have successfully converted this into an upper triangular row-reduced matrix. So now it's relatively easy to solve with Gaussian elimination, with substitution. So the first column is x, second column is y, third column is z. So this first equation, 1x minus 2y plus 4z is negative 7. Second column, 0x, that doesn't bother us, plus 1x minus 1y minus 7z is 19. 0x plus 0y, 1z is negative 3. So we actually get 3 equations, and here they are. So again, the bottom one is what I want to focus on. 0x plus 0y plus 1z is negative 3. Fine, 1z is negative 3. That's great. Now the one above it, y minus 7z is 19. Plug the z is negative 3 into the one above it. So y minus 7z is 19. Plug the negative 3 in. So I will get y minus 7 times negative 3, or y plus 21 is 19. So subtracting 21, we get y is negative 2. And then we'll finish by going to the top equation. X minus 2y plus 4z is negative 7. We're going to plug the negative 2 in for y and the negative 3 in for z, which will give me x plus 4 minus 12 equals negative 7. 4 minus 12, negative 8. X minus 8 equals negative 7. Add 8 to both sides, 8 minus 7, and we would get x equals 1. So my answer to this 3 by 3 system of equations, x is 1, y is negative 2, and z is negative 3. Always a good idea to check. Maybe use a calculator to do that, or do it mentally. But I put the answer down. X is 1, y is negative 2, z is negative 3. As an ordered triple, these are 3 planes intersecting. This is the point of intersection. And I use curly braces to indicate a solution set. So we got one more to do. X minus 3y plus 5z is 11. 3x minus 4y plus z is 14. 5x minus 2y plus 3z is 20. Going to make an augmented matrix. First column, 1, 3, 5. Second column, negative 3, negative 4, negative 2. Third column, 5, 1, 3. After the vertical line, 11, 14, 20. So our process is to make the upper left a 1. It is. Make both numbers underneath zeros. So we'll take row 2 is negative 3 times row 1 plus row 2. Negative 3 times 1 is negative 3, plus 3 would give me 0. That gives me a 0 in that spot, which is what I want. Negative 3 times row 1, negative 3, positive 9, negative 15, negative 33. Add that to row 2, 3, negative 4, 1, 14, and we get 0. 5, negative 14, negative 19. So that becomes my new row 2, replacing the old row 2. So I have the 1 in the upper left and the 0 underneath. Next, I need to eliminate that 5. So we're going to multiply the first row by negative 5, add it to the third row. Row 3, negative 5 times row 1 plus row 3. Negative 5 times 1, negative 5. Negative 5 times negative 3, positive 15. Negative 5 times 5, negative 25. Negative 5 times 11, negative 55. Add that to row 3, and we get 5, negative 2, 3, 20. 0, 15 minus 2, 13. Negative 25 and 3, negative 22, negative 55 and 20, negative 35. This is my new row 3, and you can see the matrix is written there. So we have successfully gotten a 1 in the upper left, zeros underneath. The next thing I need is a 1 here where there is a 5. So how do I turn a 5 into a 1? Divide the entire row by 5. So my new row 2 will be the old row 2 divided by 5, which will bring in fractions, which a calculator will certainly help. 0 divided by 0 is 0, 5 divided by 5 is 1. Negative 14 divided by 5 is negative 14 fifths. Negative 19 divided by 5 is negative 19 fifths. And this becomes my new row 2. So again, follow our process, 1, 0, 0, 1. Now I have to get rid of that 13. So I need to multiply the second row by negative 13 and add it to the third row. So here's our current matrix. Multiplying this row by negative 13 is going to give me some very ugly numbers. So negative 13 times row 2, so 0, negative 13, and then some other things. Negative 13 times negative 14 fifths is 182 fifths. Negative 13 times negative 19, 247 fifths. Add that to the third row, 0, 13, negative 22, negative 35, and I strongly suggest you use a calculator. And we get 0, 0, 72 fifths, which looks unpleasant, but will actually be relatively nice. Because the last thing I'm going to need is a 1 in this slot. So I can divide everything by 72 fifths or multiply everything by 5/72 to go ahead to turn that into a 1, which will also turn this piece into a 1. So let's see what we get there. So again, we need the 1, multiply by 5/72 or divide by 72 fifths, that's equivalent. And they'll give me 0, 0, 1, 1, which becomes my new row 3, and now I have it in upper triangular form, which gives me 3 equations that are easy to solve with substitution. Starting in the bottom, 0x plus 0y plus 1z is 1. So 1z is 1, of course z equals 1. Now moving up one above, 0x plus 1y minus 14 fifths z equals negative 19 fifths. Pretty unpleasant. But the fact is z is 1, so we get y minus 14 fifths equals negative 19 fifths. Not so bad. So then we're going to add 14 fifths to both sides. So we're going to get y is 14 fifths minus 19 fifths, or negative 19 fifths plus 14 fifths, negative 5 fifths, or negative 1. So z is 1, y is negative 1 with our substitution. Now we go all the way back to the top, which is 1x minus 3y plus 5z is 11. We know y is negative 1. We know z is positive 1. So it'll give me x plus 3 plus 5 equals 11. X plus 8 is 11, which gives me, of course, that x equals 3. So these are not 3 lines. These are actually 3 planes. They intersect in a single point at the point where x is 3, y is negative 1, z equals 1. I encourage you to either check on your calculator or do a mental check, some way to make sure that that set of values satisfies each of the 3 equations, which it does. So our answer is 3, negative 1, 1. Our solution set is the single point 3, negative 1, 1. And that will conclude this lesson.